Hi guys, so today we are going to see how to predict the weight of a person based on the height using linear regression. So regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent and independent variable. What it basically does is it helps us to understand the relationship between the dependent and independent variables. Um, some examples of this would be factors determining the market trends, prediction of road accidents due to DUI, and so on. So, this regression is used to estimate the relationship between the target and the independent variable. And it also finds trends in data and helps us to predict real or continuous values. Types of regression would be linear regression, logistic regression, decision tree regression. Now, moving on to the main task, today we are going to solve this by using linear regression. What linear regression algorithm does is that it shows a linear relationship between a dependent variable and an independent variable, giving us a linear equation with a slope. Now, in this problem, height is the independent variable because weight has been predicted on factors of height and gender. So for this execution of this task, I have used Google Colab, as you can see. So we'll open a new file and upload the dataset. This is the new file and upload the dataset. Dataset can be uploaded either access using Google Drive or you can upload it just for this session and it will get deleted. Now we will start. This is just an additional step. You can do this or not. It avoids errors and warnings. So first what we will do is we import two important libraries, NumPy as NP and Pandas as PD. Basically, what NumPy does is it is used for working with arrays in linear algebra, matrices, and Fourier transforms. Whereas Pandas is mainly used for data analysis and associated tabular data in data frame formats, importing data from various file formats such as CSV and SQL. Now, we read our data set by creating a variable data and we assign the values of the data set to it using pd.read CSV. Now, this is the file name. You enter it over here, the dataset name. Now, data.head is a smaller way of representation of our data set. What it basically does is it shows the first five values or the respective amount of variables or values that you want to see. So here I've done 15. Now, we have three columns, gender, height, and weight. Here, gender and height are the independent variables and weight is the dependent variable. Now we will use the function data.describe. What this function is used to do is to view basic statistical data like percentile, mean, standard deviation. So here you can see all that. You can see the count, you can see the mean, standard deviation, the max and min, like all of that you can see over that over here. Now let's move on. Okay, so here what I have done is what linear regression requires is that the data should be in numerical format. But here in the gender, under the gender column, we have data such as male and female, right? So we have to convert it to a more categorical data. So what we do is we replace all the values of female with 0 and male with 1. Now data.head just to see if it has been replaced. As you can see over here, all of the male values have been changed to 1. And data.tail is for the end of the dataset values. So over here you can see that the value has been changed, replaced to 0. Right? I think that is what you can see, right? Now, I have put gender and height as X variable and allotted this weight category as Y variable using the ilog function. Now, let's print this X and Y. So we will get an idea of how it looks. So all the values is means into array values, array of two-dimensional for X, and if we print Y, you can see one-dimensional array values. So what we do is, so what this ilog function does is, it helps to select a specified row or column from the data set. Using this function, we can easily retrieve any particular value from a row or column using the index value. Now comes the main part. Um, After this, here we are using data.shape function, which is used to tell you the number of columns and rows. This is the main part of our entire task, where we split our training and test data. So for that, what I have done is imported sklearn.model selection and imported the train test split. All right. So after that, I will separate it for extreme X test and this test equal to train test split. Uh, I think we can see that over here. Now to implement linear regression, so sklearn.linearModel.import linear regression. From here, we import our new description function. So I'm going to take a variable lin_r where I'm going to assign this linear regression function. Once after assigning it, we fit this training set to the linear regression using this lin_r.fit function. So xtrain and ytrain, it has successfully trained them. So let us predict using the test value. And along with that, we will also predict the score. Here you can see we get a score of around 85%, which means our training has been successful. Now let us predict the error as well. Here we use the root mean square technique. Now after predicting the error, let's predict a random value. Let's say a person's height is 66.5 inches. So that person's weight would be approximately around 162.48 pounds. Now here I will show you what I have done. I have plotted a graph that will show you the relationship between the actual values and the predicted values. As you can see in this graph, the purple points are the actual points or the test points, and this orange line is basically the predicted values. So that's all I have for you all. Thank you for watching.